show how to work with radicals, and by working with radicals I mean really simplifying radical expressions. And I think it's important to remember that radicals are exponents, they're fraction exponents, even though we don't always write it that way. And so properties of exponents that we've already looked at will apply in simplifying these. For example, here in A I have the square root of 9x squared. Now remember, that means that I could just say this is the square root of 9 times the square root of x squared. The square root of 9 is 3, and anytime I have something like this, a to the n to the 1 over n power, and another way of saying that is the nth root of a to the n, those simplify to the absolute value of a, if n is even. Okay, so here the square root of x squared then simplifies to the absolute value of x. Okay, now moving on to part B, this time we want to look at the cube root of negative 8 x to the 6th, y to the 9th. So remember that is the same as saying the cube root of negative 8 times, instead of saying the cube root this time, I'm going to say x to the 6th to the 1/3 power and y to the 9th to the 1/3 power. Okay, because remember, when I have the nth root of something, that's another way of saying to the 1 over n exponent. Okay, now the reason I did it that way is because I can easily think of something that multiplies times itself 3 times to give me negative 8. That would be negative 2. And then x to the 6th raised to the 1/3 power through properties of exponents, that means I simply multiply their exponents. So 6 times 1/3, I get 6/3. And 9 times 1/3, I get 9/3. And then using properties of fractions, I can reduce x to the 6/3 as x squared and y to the 9/3 as y cubed. Alright, now since this is a odd degree radical, I don't have to worry about this property that we had to worry about with part A, but we will have to worry about that in part C. Alright, so let's look at part C. So I'm going to use properties of exponents again. What I'm going to do this time is I want to bring everything into the numerator. So I'm going to have the square root of x squared 4 to the negative 1 power, because remember, anytime I bring something up, I make the exponent negative. X to the negative 4, y to the negative 6, like that. And then I can simplify like this. Let's bring together the x's. So if I'm going to multiply x squared times x to the negative 4, that means I add their exponents. So I get x to the negative 2 and y to the negative 6. Okay. Okay, now since everything is negative, maybe it would be useful to bring it all back down like this. And actually, through properties of exponents, I could write it like this if I wanted to. Square root of the numerator over the square root of the denominator. Now the square root of the numerator is just 1, so I just need to worry about the denominator. The square root of 4 is 2. The square root of x squared, well, we said that's the absolute value of x. And the square root of y to the 6, I'll just work it out here in scratch work real quick. That's 6 to the 1/2 power. So that's going to be y to the 6/2 power, which would end up with y cubed. So there it is. This square root is actually the same as this expression, 1 over 2 absolute value of x, y cubed. Okay, we're going to do a similar thing with part D. We have the 5th power, or the 5th root here. And this time, since my denominator and my numerators have no common terms or variables, it's not very helpful for me to bring everything up to the numerator, because I can clearly see here if I have the 5th root of y 30th, z to the 25th power, over the 5th root of 32x to the 5th, I believe I can work all this out. Okay, so if I use the fact that the 5th root is the 1/5 power, I have y to the 35th power times z to the 25 over 5 power. The denominator I have the 5th root of 32, so what times itself 5 times in a row gives me 32. That's 2. There's not a lot of 5th roots we know, or off the top of our head, but the 5th root of 32 being 2 is one that's very common. And then I have x to the 5 over 5 power. So when I reduce this down, that's going to give me y to the 6th, z to the 5th over 2x. and I don't have to worry about the absolute value because this is an odd radical. Okay, so now I want to go over a few more examples. They're just practicing using these root properties because sometimes it can be a little confusing. All right, so for example, part A, I have 32 to the negative 3/5 power. Okay, so that can be written as several ways. The way that's most helpful to us here is if I have the 5th root of 32 raised to the negative 3 power. Right, I can do that because remember, the nth root of a to the m is the same as the nth root of a to the m, and that's the same as a to the m over n power. So since I had a 3/5 power, I could apply the denominator as the root. So the denominator of the exponent always goes to the root. That's the 5th root of 32 raised to the negative 3 power. And I think it's easiest to look at it this way because we just said, well, I know what the 5th root of 32 is. It's 2. So now I think about 2 to the negative 3 power. The negative means I bring it down to the numerator. So I have 1 over 2 cubed, which gives me 1/8. So 32 to the negative 3/5 power is 1/8. Okay, now in part B, I want to do something similar. And it's very tempting to try to distribute that 1/3 power over everything. This is a great time to point out a very important principle that a lot of people get wrong. So a plus b to the n power is not a to the n plus b to the n. They are not the same. So what that means then is the square root of a plus b is not the same as the square root of a plus the square root of b. And that's something that people try to do very often. Okay, so in part B, I can't distribute that 1/3, so what can I do? Well, notice I have the same thing times itself. The powers are the only thing that are different. So anytime I multiply two things together, I add their powers. So this is going to be 3x squared to the 4th to the 1/3 plus 5/3 power, which ends up being the 6/3 power. So this ends up being 3x minus 4. 6 over 3 reduces down to 2. So this is 3x squared minus 4 quantity squared. Looking now at part C, it may be easiest to rewrite these as fractions. This is n to the 9/7 power times n to the 5/7 power. Remember, when I multiply, what do I do to their exponents? I add the exponents. So this is n to the 14/7 power, which is the same thing as n squared. Okay, for part D, I have a cube root of a 5th root of y to the 25th power. That looks confusing. So this time it's very useful to write this using our idea of fractional exponents. This is y to the 25th raised to the 1/5 power, and all that raised to the 1/3 power. Okay, so now using properties of exponents, that means on the inside I have y to the 25/5 power raised to the 1/3, and 25/5 is 5, right? So I have y to the 5th raised to the 1/3 power, and so that would be y to the 5/3 power being my answer. Now if I wanted to get it back into the root notation, I could say that this is the cube root of y to the 5th. Oh, but remember, the cube root of y to the 5th, that's the same thing as saying the cube root of y times y times y times y times y. And so since there are 3 of those, that means I can take out one y, and I'm left with the cube root of y squared. So the cube root of the 5th root of y to the 25th power reduces down to y times the cube root of y squared. Okay, or maybe an easier way of writing that is y to the 5/3 power. So lastly, looking at E, we have a minus b to the negative 2/3 power all over a minus b to the negative 2 power. Okay, so this time, since I'm dividing, it would be easiest to multiply by its reciprocal, or in other words, let's take that negative 2 in the denominator. We're going to bring everything up to the numerator and flip the sign of that negative 2 to give me positive 2. That way, when I multiply, all I have to do is add the exponents. So that's negative 2/3 plus 2. Okay, now on the side here, I'm going to do a little bit of scratch work. Negative 2/3 plus 2 is the same thing as negative 2/3 plus getting a common denominator, multiplying by 3 over 3 here. I get 6 over 3, so I end up with 4/3. Okay, so that means then I have a minus b to the 4/3 power. And you could write that as the cube root of a minus b raised to the fourth power if you want, or you can just leave it like this. I hope going through these exercises helps you feel better about using fraction notation for exponents, for radicals, as well as understanding properties of radicals and how to manipulate expressions using radicals and exponents. If you have any questions on this, please let me know. I'll be glad to help, and thanks for watching.